Welcome to the explainer. Imagine for just a second that you are walking into a courtroom. The stakes? They are incredibly high. The judge is sitting there waiting, and you have to prove your case absolutely beyond a shadow of a doubt. Now, you can't just stand there and throw random, disconnected facts at the judge, right? You need a meticulously structured argument. You need compelling, rock-solid evidence. And you need an undeniable conclusion. Well, let me tell you, sitting down for your Cambridge mathematics exams, and it doesn't matter if you are tackling syllabus codes 0580, 0606, 4024, 4037, or 4040, is exactly like that high-stakes legal case. The examiner is the judge, and today we are acting as your ultimate legal counsel. We are going to master one of the most notoriously tricky, absolutely guaranteed to appear topics in the Cambridge Additional Mathematics 0606 syllabus. We're talking about restricting the domain of a function so that its inverse or its composite relationships can validly exist. Over the next few minutes, we are going to build your mathematical case like a top-tier barrister. Okay, let's dive into this. We've got a 5-step system to get through today. We'll start with Act 1, the challenge, to see what we're up against. Then Act 2, the strategy reveal. Act 3 is the transformation. Act 4 is our fast-paced interactive workshop. And finally, Act 5, the final verdict. Let's start building your case.
Act 1, the challenge, the examiner's warning.
The tension is literally palpable in the exam hall when this question pops up. This topic, restricting the domain to allow an inverse function, which we call F inverse, or a composite function GF to exist, is an absolute non-negotiable. It is guaranteed to appear in your paper. Yet, thousands of candidates walk right into the exact same traps set by the examiners year after year after year. Let's look at the evidence. We constantly see two classic archetypes of flawed candidates. On the left, we have Alex. Now, Alex overloads the page with raw mathematical facts and a massive wall of chaotic algebra. There is zero analytical depth here. It's just an explosion of numbers, completely ignoring the logical, step-by-step argument that the examiner is actually looking for. Then, on the right, we have Sam. Sam's problem is entirely different. Sam rushes the problem, jotting down a quick answer based on a gut feeling, and completely missing the actual command word requirements like show that or hence. The examiner doesn't want chaos, and they don't want a rushed guess. The examiner wants a structured, logical, legal brief.
Now, you do not just have to take my word for it. Listen to this explicit quote derived directly from the principal examiner reports themselves. Mastering restricting the domain of F for F inverse and or GF to exist is essential. This topic appears in every examination series. Did you catch that? Every single series. You literally cannot hide from this topic. Whether you are just aiming for that baseline pass to get through, or you're shooting for the absolute top-grade boundary, your ability to logically argue why a domain must be restricted, which is usually to ensure a function is one-to-one so its inverse can exist, is a fundamental, foundational pillar of your Cambridge mathematics success. Act 2, the strategy reveal, the theoretical foundations. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Now, what's really interesting about this slide is how the entire theoretical architecture of this topic rests entirely on precise definitions. Restricting the domain simply means consciously limiting the input values, those are your x values, of a function f. But why do we do this? Well, it's because for an inverse function to mathematically and validly exist, the original function absolutely must be a one-to-one mapping. Think about a standard quadratic curve, right? The classic parabola shape. It goes down to a minimum point and goes back up. That is a many-to-one function. If you try to invert that whole curve without restricting the domain to just one half of it, usually from the turning point onwards, the mathematical relationship completely breaks down. One input would give you two outputs, and that is not a valid function. You must restrict the input to ensure the inverse is mathematically solid. To properly argue this case in the exam, you really need to understand the assessment objectives that the examiners are using to judge your work. They are targeting very distinct cognitive domains. First, your knowledge and understanding of the terminology itself. Second, the correct, flowless application of mathematical principles. And third, they heavily prioritize analytical depth over superficial breadth. This is exactly where the Peel framework comes into play perfectly. You might know Peel from English class, but it works wonders in high-level math. P is for point. Clearly state the domain restriction. E is for evidence. Find the vertex or turning point algebraically, perhaps by completing the square. E is for explanation. Explicitly write down that this restriction creates a one-to-one function. And L is for link.
Connect this back to the question, proving the valid existence of the inverse. This framework is how you prove your case beyond a shadow of a doubt. So let's see how this all builds into the famous method mark strategy. In Cambridge additional math, marks are heavily awarded for the process, not just that final number at the bottom of the page. Step 1. Identify the key elements. You need to find the given function and immediately recognize its type. Step 2. Apply relevant principles. For instance, if it's a quadratic, you know you're probably going to need to complete the square or use differentiation to find that minimum or maximum point. Step 3. Execute your analysis with crystal clear working. Show every single step of your algebraic manipulation. Do not skip steps in your head. Step 4. Verify the results. Ask yourself, does your restricted domain actually map correctly to the required range? And finally, Step 5. Present an appropriate format. Use the proper mathematical inequality notation. If you follow this step-by-step legal framework, you are going to secure those precious method marks, even if you make a tiny arithmetic slip somewhere along the way.
Act 3, the transformation. Building the system. All right, so we've established the theory. Now it is time for the practical application. Because let's face it, managing your cognitive effort in the pressure cooker of the exam hall is just as important as the math itself. Let's look at the timeline for a standard 5-mark question. Minute 1 is entirely for deconstruction. Don't even pick up your calculator yet. Identify the given information, extract the data, and decode the command words. Are they asking you to state, calculate, or justify? Those words completely change what you have to do. Minute 3 is for solving. This is where you break the problem into logical steps and execute them systematically, using that Peel methodology we talked about. Finally, Minute 5 is evaluate. Check your answer for reasonableness. If you've restricted a domain for an inverse function, does your new range actually match the original restricted domain? It has to. You must evaluate your own evidence before you hand it over to the judge. Let's look at the stark contrast between a flawed and a flawless approach. A flawed response, like what our friend Sam might write, confuses terminology. They might confuse the range with the domain, and they completely ignore the context of the question. Conversely, a flawless, top-scoring response uses cross-topic connections brilliantly. A top student might actually use differentiation from calculus to quickly find the turning point of a curve to perfectly justify their domain restriction. They justify every single decision with hard mathematical evidence. They're questioning their own assumptions and proving their logic on the page. That is the exact difference between a decent passing grade and hitting that top grade boundary. I want to pause right here and highlight this massive red flag pulled straight from the principal examiner reports. Examiner alert. Candidates consistently confuse key terminology. Always define terms before using them in extended responses. Knowing the exact difference between the domain, the range, a one-to-one function, and a many-to-one function is your primary vocabulary in this courtroom. Stop scrolling, subscribe to our YouTube channel, Ace the Exams. At AceTheExams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at AceTheExams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Act 4, Interactive Workshop. Evaluate evidence quality. Okay, we are moving into a fast-paced interactive workshop right now. I am going to challenge you to evaluate evidence quality just like an examiner would. I've got a mental 60-second timer going, and I want you to look at the top 3 mistakes pulled straight from the Cambridge examiner reports. Number 1, using the wrong approach for the wrong context. This means trying to invert a function without even checking if it's one-to-one first. That's a fatal flaw. Number 2, forgetting to check format and presentation. Imagine you did all the complex algebra perfectly, but you wrote the final domain using the wrong inequality symbols or the wrong type of brackets. You just threw marks away. And number 3, providing answers that are not specific to the context given. If the question involves real-world physical measurements, a negative domain restriction might not make any logical sense. I highly encourage you to pull out your most recent practice paper later today and cross-reference your answers against these 3 specific flaws. Are you guilty of any of these? If you find yourself struggling to remember all these abstract rules when you're under pressure, I want you to use this visual story memory hack. It's incredibly effective to encode complex domain restrictions. Picture the function f as a giant physical machine in a factory. The domain is the intake valve of that machine. Now, if you try to run the machine in reverse, which is our inverse function, f inverse, but the intake valve allowed too many confusing, overlapping materials in initially, the machine is going to jam. It breaks. Restricting the domain is basically like installing a very precise, high-tech filter on that intake valve, ensuring that only perfectly sorted materials enter in the first place, so the machine can run backward absolutely flawlessly.
Visualize that factory machine in the exam, and you will literally never forget the logic of domain restrictions again. Act 5, the final verdict, the complete answering system. We have reviewed the theory, we have analyzed the mistakes, and we have built a solid case. But remember, in mathematics as in law, presentation is power. The presentation of your information follows strict conventions that you simply must memorize. First, use proper headings or spacing to segment your working so it isn't just a wall of numbers. Second, use correct terminology. Write words like domain, range, and inverse accurately when explaining your steps. Third, use appropriate formats. This means precise algebraic notation for your inequalities. Don't use a less than sign when it should be less than or equal to. And finally, clear annotation. You want to make it incredibly easy for the examiner to follow your logical steps. A brilliant mathematical mind will still lose marks if their legal brief is a disorganized, chaotic mess. So the crucial point is this. Here is the 3-step definitive rule system that absolutely guarantees top marks on examination day. Rule 1. Extract the relevant data, decode the command words, and select your analytical framework, like choosing whether to use completing the square or differentiation to find your turning point. Rule 2. Execute the algebra with crystal clear notation, applying that Peel framework to justify exactly why you chose your specific turning point for the restriction. Point, evidence, explanation, link. Rule 3. Present the final domain restriction with perfect mathematical terminology and evaluate its reasonableness against the original function. If you follow this exact system, your mathematical argument becomes completely bulletproof.
Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by.
We've built the case, we've presented the evidence, and now the judge's gavel has fallen. But your preparation certainly doesn't end here today. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.